Hey everybody, Mr. Bohoric here, and today I would like to do solving equations with radicals. If you have not watched the videos on squares and square roots and cube roots, you're going to want to do that because you need to know how to do these in order to solve equations with radicals. So let's go ahead and get started, and we're going to start with a really basic example. Okay, we're going to start with, and I'll number these. I'll start with number 1. And we're going to start with really basic square root of x is equal to 81. I'm sorry, is equal to 9, excuse me. All right, so you probably already know what the answer is. In fact, I accidentally just said the answer. Yes, it is 81. That's how easy these are, as I actually stumbled the answer out of my mouth before I even finished writing the problem. But we want to go ahead and practice the proper way on how to write these by doing the correct operations to both sides. Now, of course, with all equations, since we are solving equations, we're going to be trying to get this variable here, x, by itself on one side. We're isolating the variable. And right now, we've got a big, fat square root radical sitting on top of it, and we got to get rid of that guy. Well, we've already learned from the squares and square roots video, which you should watch if you haven't already, okay, that you should square to get rid of a square root. So we need to raise this to the second power to get rid of a square root. Well, this is an equation. We're not allowed to just do things to one side and, not do anything to the other. That'd be like going to the gym and putting like 300 pounds on one side of the weight bar and then adding 5 pounds to the other side of the weight bar. That doesn't make any sense at all. Okay, you have to do the same thing to both sides. So let's go ahead and square both sides. So we want to square both sides of this equation. So, what happens there? Well, something awesome happens. A square and a square root, they're inverse operations. They cancel one another out. So you're left with the radicand, which is the number underneath the radical. Okay, and that's an x. So all we're left with now is x. Okay, we know what 9 squared is. That's 81. So that confirms my answer that I accidentally blurted out. The answer is 81. And double check yourself. Okay, is the square root of 81 9? Well, yeah, it is. Okay, so we're good to go. So that was a really basic example of solving an equation with radicals. Let's add a little bit more to that. What if I had the square root of x plus 1 equals 7? The square root of x plus 1 equals 7. Now, in general, with these radical problems, these solving equations radical problems, I want to try to get the square root by itself, or I want to try to get the square by itself, or cube root by itself, okay, because that's like the last operation I want to go for. I tend to think of, I want to undo operations in order of least powerful to most powerful. So kind of addition and subtraction I kind of want to get rid of first. Multiplication, division next, and then finally squares and square roots, because those are pretty powerful operations. So that means that I see a plus 1 right here, so let's get rid of that by subtracting 1 on both sides. So we're going to subtract 1 on both sides, and that's going to get the radical by itself. So when I do that, I end up with the square root of x from up there is equal to 6. Just like we did in the last problem, okay, to get rid of a square root, I'm going to want to square both sides. Square both sides so that these will cancel out, leaving me with just the radicand. Okay, just the radicand is left. So I'll end up with x, the radicand, is equal to 36, because that's 6 squared. Double check your answer. The square root of 36, that's 6, plus 1, hey, cool, is 7. So we definitely have the right answer here. X equals 36. Now let's continue. I didn't do any with squares, so let's do one with a square. Number 3 here. Let's do x squared plus 12 equals 156. Again, like the last one, I want to get the square by itself. X is being squared here. I don't want to get that by itself. So let's subtract 12 on both sides first. So I'm going to subtract 12 here and here. And let's take a look at what that gives me. Well, that gives me x squared from over here is equal to 144. 156 minus 12 is 144. Now, like last time, but kind of the opposite, x is being squared. So what's the opposite of squaring something? Square rooting it. So I want to square root both sides. Just like before, a square root and a square will cancel out, and that leaves us with just an x. And the square root of 144 is 12. And you may be out there in YouTube land saying, wait a minute, isn't it 12 and negative 12? But remember, these videos are intended for a pre-algebra class, and we're only concerned with the principal root. So 12 is going to be our answer. Even though we know negative 12 works, okay, we're just going to choose 12 as our answer. And double check that. 12 squared is 144, plus 12 is 156. Excellent. Let's move on to the next one. I'm going to change it up just a little bit. What if I had the square root of x plus 1? And that equaled 15. Now remember, I want to get the square root, square, cube, or cube root. I want to get that by itself. Well, this square root is by itself. There's nothing on the outside of the square root. We just have the square root and the stuff that's under it. So it is already by itself. You cannot subtract 1 on both sides. I like to think of it as it's being trapped underneath that square root. So you have to get rid of the square root first. So what should we do to both sides? Well, if we have a square root and we want to get rid of it, we square both sides. So let's square both sides. Just like before, the square and the square root will cancel out, leaving us with whatever's in the radicand, and that is x plus 1. So that's all that's left over, x plus 1. And it's left with 15 squared, which is 225. From here, it's very, very easy to do this equation. Subtract 1 on both sides, and we'll have our answer. Okay, so x is going to be 224. And that's going to be our answer here. And plug that back in. 224 plus 1 is 225. The square root of 225 is 15, and that's what it equaled, 15. So we are all set. Let's keep going. Let's do a few more of these. Let's do, let's say, oh, I don't know. How about x minus 3 squared equals 16? Okay. So we've got the square is by itself. The square is by itself. See, there's nothing on the outside of that square. It's just this thing inside being squared. So to get rid of that square, since we can't add 3 to both sides, we got to get rid of the square first. To get rid of the square, we do the opposite. So square root both sides. Just like before, the square root and a square will cancel out, leaving us with whatever's left over, and that's x minus 3. And the square root of 16 is 4. From here, it's really not bad at all. Let's add 3 to both sides. And our final answer is going to be x equals 7. Awesome. It should be a 7. Looks pretty bad. X equals 7. Plug it back in. 7 minus 3. Yeah, okay, cool. That's 4. 4 squared. Cool. 16. Sweet, we're all set. And let's do one more. What if I had 2 times the cube root of x plus 1 equals 8? Whoa. Okay, well, I want to get the square, square root, cube, or cube root by itself first. And this cube root is not by itself. There is a 2 in front of it. And I need to get rid of that 2. So what do I do to get rid of the 2? I want to divide both sides by 2. So those 2's will cancel out, leaving me with the cube root of x plus 1 is equal to 8 over 2 is 4. From here, I've got the cube root of x plus 1. So what should I do to get rid of a cube root? Well, cube it. Remember, it's an equation, so we got to cube both sides. Just like before, a cube and a cube root will cancel out, leaving us with, wrong color, there we go, leaving us with x plus 1 equals 4 to the third power is 64. Subtract 1 on both sides, and our final answer, I think I'm running out of space, so I'll write it up here. Our final answer is x equals 63. And to check our answer, Let's go ahead and do that real quick. 63 plus 1 is 64. The cube root of 64 is 4. And 4 times 2 is 8. So it definitely works. All right, I'm Mr. Bork, and those were some pretty good examples with solving equations with radicals.